Hello everyone, my project is automatic generation of icons and my supervisor is Yanni. Today I'm going to present the results that are generated by the game model and how we came up with these results. Game is a powerful generative model that it can generate the distributions which are very close to the real dataset. But again, it's notorious for its instability. During training, the model crashes easily due to many unknown factors. So first of all, I'm going to introduce the parameters of the model that we can tune to improve the stability. Intuitively, we might think that in order to trick the discriminator, we should let the generator be smarter to learn or learn faster than the discriminator. So for example, we can add more layers or increase the number of filters to the generator like here, here. Or we can train the generator twice while we only train the discriminator once in each iteration. And this was what I did when I first started, but I found that this is not a very efficient way to deal with the instability issue. So next, I want to show the other four things which are helpful to improve the stability. The first one is 2 timescale update rule. This sounds fancy, but it actually just using different learning rate for the discriminator and the generator. Usually we set the learning rate for the discriminator around 0.0004 and it's 4 times faster than the generator. But the value will be slightly different depends on the dataset. The second one is using spectral for each layer of the discriminator. Spectral constrains the Lipschitz constants of convolutional layers. Anyway, it's an iterative way to approximate the regularization term. And sometimes using spectral for the generator is good as well. The third and fourth parameters are adding noise to the inputs of the discriminator and doing label smoothing. So as you can see, these are real images and fake images. And we add noise both here and here. And this is the label smoothing part. So instead of using 1 for the real images and 0 for the fake images, we choose some number that are very close to 0 and 1. So for example, we choose 0.9 here and 0.05 here. By doing so, we can prevent the discriminator from being too confident, and this helps the generator to learn properly. Next, I'm going to show how they work on my Google Colab notebook. In this example, I only add noise and do label smoothing without using spectral. So you can see I use spectral here. I use batch here. Sorry. I use pre-trained way, so we don't need to train the model now. So okay, this is the result. Yeah, this is an example of model collapsing. So in next example, I use spectral for each layer of the discriminator and without adding noise and label smoothing. So as you can see, this is another example of model collapsing. Okay. So if we add both spectral to the inputs and do the label smoothing and add noise, yeah, we can see from the result the model start to extract the distribution from the dataset. But it seems that there are still runs to improve the model. So in order to improve the quality of images, I tried the other two methods. The procedure of the first one is using the autoencoder to preprocess images. I transfer the images to the latent space through this encoder and use k-means clustering methods to cluster images. Then I train the model cluster by cluster. So this is the result from the autoencoder. So this is the original dataset. This is the decoded one. So I didn't use very deep layer for the autoencoder, yeah, considering to the efficiency of computation. But the result is good enough for doing clustering. And next is the result of k-means. Yeah, the number here is not very clear, but it shows that k equal to 4 is a good choice for this data set. So after clustering, I let the model learn cluster by cluster, expecting that it could learn better by this way. But however, the model crashed when I used different cluster to train it. Yeah, this is the result. Yeah, when I change cluster. So it turns out that the model cannot be trained by separated dataset in this way. So to me, it feels like the model doesn't know what type of images it should generate, and there are much more than 4 types of images in this dataset, I guess. I feel that if I could tell the model which specific type it should generate, maybe I could improve the quality of images. Since training cluster by cluster didn't work, I searched for another way to use the information of clusters. So from some papers and articles, they suggest that if there are labels there, we should use them. If there are no labels, and we can create some labels. So I tried the other way to use the information of clusters. I still use autoencoder to preprocess images in the same way, but instead of using k-means clustering, I use Gaussian mixture model this time, and to create 100 clusters and label these images from 1 to 100 based on which cluster they belong to. The labels are encoded into one hard format. Then I train the conditional gain based on these labels. The structure of the conditional gain is shown here. The label information is merged to the convolutional layer in this way. Given these labels, the model can learn more specifically of what it should generate. And this is a result from conditional gain. Yep. So we can see the quality improves a bit here. So in conclusion, when dealing with the instability issues of game, I would consider these 4 parameters first. And if they are labels, I will try to build a conditional game to utilize this label first. So all of my code will be available on GitHub, and the weights and dataset is on my Google Drive. So any cohort who is going to continue this project can use them. Or if you are interested, you can play with the code. So thanks for listening.